Hey guys, welcome back. In this video, let's discuss about the commonly encountered problems while working with Kubernetes pods. Basically, we will see the debugging skills of Kubernetes pods. The pods can fail because of various reasons, but it's difficult to cover all of them in a single video. And I will be focusing mainly on the following four issues we commonly see while working in Kubernetes pods. The first one is ImagePullBackoff. We'll see what is that exception, when we get it, how to find it. So we're going to see all these four issues in a demonstration. Yeah, let's get started. Alright, for the purpose of this demonstration, I have created a simple pod YAML document, and the specification is it's going to deploy the image I pre-created in my Docker Hub account. So this is the pod we're gonna use for learning debugging skills. Yeah, let's get started on it. So I have a Kubernetes cluster created in Amazon EKS, and I have access to that cluster. For you guys to follow along, you must have a Kubernetes cluster. Right now, the cluster is not having pods. Let's go and create our first pod. The pod.yml I just shown you in my Visual Studio Code. That's the file here. So let's take this and create kubectl create -f pod.yml. This submits the request to API server in Kubernetes, and if everything goes good, Kubernetes cluster will create this pod and keeps it in running state. Let's list pods by executing kubectl get pods. Here this pod is successful, it's in running state. Of course, this pod doesn't have any problems, but we are starting with a good pod which is in running state. Alright, now the first thing we do when we debug issues in pod, we use describe command. Kubectl describe pod name of the pod. This command is super useful because it presents the information about the events happening on this pod in the background. It's presenting as lots of details: name, namespace, the node where this pod got scheduled, start time, labels, annotations, IP address, and the status. If you move completely to the bottom, we see event section. So this is very useful when we debug pods. And under event sections, the first event says scheduled. Yeah, when we submit request to Kubernetes cluster, it is received by API server, and API server talks to a scheduler and asks for a node, the right node to schedule this pod. That event is successful, and the next event is, after finding out a right node, the next event is the kubelet on that node is creating the container. So first it usually pulls the image, because image is already present, it's directly getting into creating the container. Then the second event is a container image. It says it's checking for container image. It's present on the node locally. If it is not present, it will go to the remote. If it is if it is your Artifactory, or if it is a Docker Hub, it goes there and gets that image. In my case, I didn't configure any private registries, so it's going and getting it from my Docker Hub account. This image is public and it's present. And next is creating container, starting container. Yeah, so these are the events of this successful pod. But we want to demonstrate a failure pod, right? This is about successful pod. We want to demonstrate about a failure pod. What I do is I terminate this pod, and for the simulation, let's prepare a pod which fails. Running delete command deletes the pod. For the purpose of simulation, I am giving wrong Docker image details. This Docker image is not present in my Docker Hub account. Save this. Create pod. Request is successfully submitted. Run get pods. We see image pull, error image pull. Means, right, it's unable to pull the image. To know more about why it is unable to pull the image, run kubectl describe command. Check events section. First event is scheduling. It found a node for scheduling this pod. And the next event is pulling image, right? And it's unable to pull the image. See, failed to pull the image, unknown. And if you thoroughly read the error code and the exception message, error response from daemon, pull access denied for this image, repository does not exist or may require permissions. See, it's saying probably there is no such image in your repository, or if that image is present, it requires username, password. If it is private image, maybe it requires username and password to access that image. But here, in our case, the image I gave does not exist. So that's a problem. To fix this problem, I need to fix Docker image name in my pod YAML document. So I have to correct, and it works. Okay guys, that's about image pull backoff issue, how to find and how to fix. And now let's talk about crash loop backoff problem. First, let's clean up. Let's delete the pod, existing pod. And for the purpose of this demo, let me choose a different image. Alpine image. And go back to the terminal. Create the pod. Pod got created. Run kubectl get pods. Okay, status says completed, and seed crash loop backoff, and restarts 1. Let's keep checking kubectl get pods command, and restarts 2. So here the pod is getting into crash loop backoff issue. Now I want to troubleshoot this. Okay, the expectation is this pod should run successfully, but it's not. it's getting into CrashLoopBackoff. Let's find why it is getting into CrashLoopBackoff. kubectl describe pods, pod name, and scheduled, then pulling image, successfully pulled image. After pulling image, creating container. After that, starting the container. And again, it's repeating this process. Correct. So I know why it is failing. I know why it is failing is, okay, we are using Alpine image and we are starting Alpine container. It starts, it executes for few milliseconds and it stops. Why? Because we don't have any running process in that container. Means if I take Tomcat pod and start it, in that Tomcat will be up and running, so that container also keeps up and running. Okay, and the pod will be running always. But in this case, we are using Alpine image. Inside Alpine image, we don't have any application, any process that starts and keeps running always. So that's the reason it's starting and the container is finishing because of restart policy. Okay, it is starting again. It's starting again. So it's starting, stopping, and that's the loop it's getting into, right? That is called this one, crash loop back off error. But sometimes we may have a pods which needs to just come up, do its job, and shut down. In such cases, we have to change the restart policy. Let's try this again by keeping restart policy never. In pod, the default restart policy is always. I want to delete old pod and after adding restart policy never to this pod, I want to create again. And I want to say get pods. That's it. See, we may have a pod which needs to come up, do its job, and stop. We don't want a continuously running pod. In such cases, we need to change the restart policy of a pod. That will just be in completed state and the Kubernetes will not try to restart because I kept restart policy never. And the next problem we are going to discuss is pod in pending state. Yeah, sometimes we deploy a pod and it keeps, Kubernetes cluster keeps that pod in pending state. Various reasons for that, and I will demonstrate one scenario where a Kubernetes keeps the pod in pending state. Yeah. So we want to simulate the problem. To simulate the problem, I'm adding node selector, key, and value. So this is the information given to Kubernetes scheduler that, hey, please schedule this pod on a node which contains memory optimized as a label key, yes, as a label value. Right. Now let's delete our old pod and create this pod and see what happens. Delete and create. Okay, we got exception directly from pod.yml. Let's fix this one. Okay guys, yeah, I found it. I fixed this problem by keeping this value in a quotes. Let's run create command. Yeah, a pod creation request is submitted successfully. Run kubectl get pods command, and yeah, it's in pending state. Okay, now again, how to find why it is in pending state? Run kubectl describe command. Kubectl describe pod node app, and under events, failed scheduling. We got 2 nodes. Out of 2 nodes, it found 0 nodes, which is matching our node labels. Kubernetes scheduler is considering this value. It's looking for a node having this label. So it's not there. There is no node having this label, so it's unable to schedule. To fix this problem, we need to make sure at least one node in Kubernetes cluster has this label. Okay, let me find how many nodes present in the cluster. So kubectl get nodes. There are 2 nodes, and let me label one node like this. Kubectl label nodes. All right, name of the node and the label we want on it. Yes, I am labeling this node with memory optimized yes, and now go and do get pods. Yes, it was in pending state. Now seems like it's moving forward, and okay. Alright, we are using Alpine image. Yeah, it got scheduled successfully and it completed and stopped. Correct. So that's one scenario when we get pending state, pod pending state, and most of the issues are troubleshooted using kubectl describe command. And let's close this discussion by talking how to check logs, application logs on pod. Okay, sometimes the problem is not at cluster level. Sometimes the problem is with the application running inside the pod. And to troubleshoot that, we want to see logs, application logs. To find logs, the command is kubectl logs and pod name. Because Alpine doesn't have any logs inside it, so it's empty. Let's do this demo by changing the image, because I want to show you some logs, at least some logs. So here, right, delete and recreate. It's in running state, and see that I could see some logs inside this pod, but this is very simple and basic application. We can't see a real-time logs, but in real world the applications will generate lots of logs, and if there is an exception, we need to run this command, locate the exception in the log file, and based on the exception we see, So based on the exception we see, the troubleshooting process will begin. So how to fix a problem? It purely depends on what is the exception. And inside the pod, we can have one or more containers. In such cases, let's say only one container is failing and other container is good. And we can find logs of a specific container in the pod. This is giving pod level logs, and to fetch container level logs -c container name. So in our case, container name is also node app. Perfect. So that's about this video, guys, and thanks for watching. We'll see you guys again later with some other useful and interesting content. Thanks a lot.